Okay, welcome everyone. Let me move this away. Thank you for spending this Friday the 13th afternoon with us. Can everybody hear me? Just say yes on the chat. I don't want to speak like for 2 hours, and then nobody can hear me. Okay, good. So hopefully all of you, thank you for those of you who have responded. So for those of you who are here, make sure that you're on the right workshop. We are doing Skaffold and Kustomize today. Generally, NUSISS runs this kind of technical workshop like once every 1.5 months to 2 months. Okay, so I think the last time that we ran was actually on, I think was on infrastructure as code. We look at I can't remember. I think we look at Terraform. Okay, so in this particular session, what we are going to do is this. We are going to look at 2 tools called Skaffold and Kustomize. For those of you who do not know, Skaffold and Kustomize are tools that actually help you with development on Kubernetes, right? Okay, so let's start. By the way, you can get access to this slide. I mean, there's not really a lot. I'm just using the slide as a placeholder. Here, you can get access to here. It's bit.ly Skaffold underscore Kustomize. If you've got questions, please post them on chat. Okay, since we are dealing with Kubernetes, my assumption is this, and this is a slightly more advanced workshop. It's not like a Kubernetes containers 101 workshop. This is like slightly more advanced. The assumption is that that you have some experience with Docker, building simple web application in Node, or in Java or in Python or whatever. You have some knowledge of writing Docker files. You don't have to really need a lot. Just a basic just a basic directive for do like from environment, run, expose. And then the second assumption I'll be making is that you have some experience with Kubernetes. You're not really a guru. You don't really need to be at a guru level. You have some experience with Kubernetes. Using the images that you have built, you deploy. You use deployment and service to deploy a Kubernetes application, and then you use config maps or secrets to configure your application. Right? We are not even going to look at things like volumes, ingress, and stuff like that. Those are the only Kubernetes resources that you need. So the assumption is that you know Docker, you know how to build simple images, and then for Kubernetes, minimum you need to know how to write a deployment, how to expose a deployment as a service, and how to configure your deployments, your pods, basically, using config maps. So let's look at, having said that, let's look at Skaffold and Kustomize. So what are Skaffold and Kustomize? As you know, a lot of Kubernetes tools actually requires you to install controllers into the cluster for it to work. Skaffold and Kustomize are 2 client-side development tools. That is only client-side. You only need to download one binary on your local machine. There are no cluster installation. You do not need to install any resources into Kubernetes. It is extremely lightweight. Both of these tools are extremely lightweight. It's a single binary, and it's actually very easy to use. And you can, if there's any error, you don't need to debug on the server side. You just look at what is generated by the binary. The 2 tools is Skaffold here and Kustomize. We look at the website in a little bit more. Okay. So before we start, let's run through how we deploy a Kubernetes application, starting from container. We won't develop the application. The application has already been developed. What we'll do is this, and the Docker file has also already been written. What we'll do is this: we will write the Kubernetes resources to deploy this. So we'll go through a manual process first, and then we'll see how these tools, how both Skaffold and Kustomize help us with this development. By the way, I will push the source, after this presentation, I'll push the source to this repository. You can pull it down from here. So I've got let's start with the JavaScript first. I've got a application. It's a very simple application. By the way, I've got a local Kubernetes cluster running. I'm using Minikube. My Minikube profile is called single. Okay, so it's actually running. And okay, so someone said, can I cut and paste the link? Yes, I can. I'll post a link on. Okay. So I've got a Kubernetes running, Minikube, and then let's look at the resources. So I've got cluster info, and we can get node. It's a single node. By the way, Kubernetes Minikube allows you to create multi-node clusters. I'm just using a single node. So the single node, the name of the node is called single. So what we're going to do is this. I've got a simple JavaScript. I've got a simple JavaScript Express application here. It's a simple web application, and what it does is this: the application has reads two environment variable. One is called instance name. Okay, one is called instance name, and the other is called instance hash. Okay, I'll show you what this does afterward. And also I've got a Docker file which I've written. So it's basically using Node 16, and then it's exposing port 3000. These are some of the files that we are going to copy into the container. I'm going to do an npm and expose the port. We will uncomment this later on. This is the health check part, and then this is how we run the run the application, right? So what I'm going to do is this, right? Since I'm going to, one of the really nice thing about Minikube is that you can actually, you don't have to run Docker locally. You can actually build, use Minikube, because Minikube is using Docker. You can actually use Minikube, get Minikube to build the image for you. And the way to do that is this, like this. So if you type the Minikube command line, right, there is this thing called docker env and podman. Okay, so these are the two environments. Since I'm using Docker, and so the way you use it like this: you go Minikube docker env. If you're just using the default Docker profile, the default Docker profile is called Minikube. You don't have to type P, but I'm not using the default Docker profile because I've got I'm not using the default Minikube profile. So I've got a few different profiles, Minikube profiles. So I'll use the single one. So you say like this. So what this does is this, it exports a few things, right? So you need to set this thing to your environment, and then you can actually look into the Minikube's Docker environment. And the way to do that is like this: you go eval Minikube minus p single, and then docker env, right? So what that will do is that will set things like the Docker host, for example. So you set this host. So now if I run Docker images, I'm actually looking at Minikube's Docker environment. Okay, so and then this is the Minikube Docker environment. These are the images. Notice these are all Kubernetes images. And then I can run Docker PS, and this will show me all the containers that are running in my Minikube. So now I will build this. I'll just go Docker build. I'll call this DOF version 1. Since I'm doing development, I do not necessarily want to push it into my Docker Hub, right? I want to push it locally so that it's much faster. And right here. Okay, so now it's going to actually start building. So remember, right? I'm doing this locally. So let me set the other few environment first while that is building. Okay, so I'm going to also need that. Okay, minus p single. Okay. Okay, so good. So it's pulling the images. It's building the image. Okay, so now we can go Docker images, and then we will see my Docker here. Okay, so now I can run this, right? So Docker run minus D. Minus D is to run it as daemon, and then we want to say port. So remember, I'm actually running my port is exposed at port 3000, right? So I'm just going to map it to local 3000. And then what I'll do is this, I will give it a name so that I can identify it because there are a lot of images in there. And then I'll just say dov v1. Okay. By the way, I can also set some environment variables. Sorry, JavaScript. Okay, I can also set some environment. Let me show you what the two environment variable does. The two environment I've got here is the hash instance. We will look more into this a little while, and then instance name, right? So we can say minus e instance name. Let's call this hello, and then I'll set the hash, and then I'll set 1, 2, 3, 4. Okay. We can run this. Let's go Docker ps grab dov. So that's up and running. Okay. So now I can look at it. Remember, I cannot do local host, right? Because I'm not running locally. I cannot do local host. I cannot do localhost 8080. It will not work. I need to get Minicube's IP address. Remember, this Docker environment that I just deployed to is not my local machine, is in Minikube. Okay. So to get Minicube's IP address, you go Minikube. Oops. IP. I need to give P single. So that's my Minikube IP address. So just copy that. Paste here, and we do 8080. So that's the application. It's a very simple application. It just randomly, every time when you refresh, it just randomly displays 4 images. The first one here, this is the name. The first one here, this is the instance name. Okay, this is the instance hash. By the way, this is my favorite. This is my favorite image. Sticker. This is how I feel now because it's Friday, right? Okay, so you just so you just go refresh, it gets a new one. Okay. And this is how I feel, when my application is not working. Okay, so now we got that. Now we got that, right? So let me delete the application first. Okay, so I've just deleted the application, so it's no longer running, right? So I've got the image built, right? Okay, I've built the image. The next thing I'm going to do now is this. I'm going to create a Kubernetes resource to deploy the application as a deployment. So I'll YAML. Okay, so I've got a YAML file. I'm going to generate this very quickly using imperative command. So kubectl create deploy, and then I'm going to give the name of my deployment is called dov. The image would be dov1. Okay, so that's my image. This thing. Okay, so that's the image name, dov1. And then the port is 3000, if you remember. I'm exposing port 3000. And then let's see what else. Okay, replicas. PLI replicas equals to, let's put it 2 replicas. Since I'm going to generate it, I'm going to output YAML, and then I'm going to say dry run client side. Okay. Oops. Okay, no problem. Okay, ctl create deploy dov image equals to dov v1 replicas equals to 2, and then port equals to 3000. So we want the output YAML, and then we will say dry run equals to client. Okay. All right, so let me just clean this up first. Okay, let me admit a few more guys. Yeah, just coming. Okay, so let us just clean this up. So we don't strategy, we don't resources, right? Okay, and so let's run through this. This is our deployment. So V1, that's the label. So to generate the 2 replicas, and since this deployment is got a selector, the match label is app.dov. So this is app.dov. This is the template. This is the pod template. Okay, and let me just change this down a little bit so it's make it easier to see. Right, this is the name of the container. It's got the pod has contained 1 container. The name of the container is called dov. The image is that. So that's the image that I'm going to use, and then that's the container pod. Okay, so let's create a config map so that we can customize the instance name as well as the as well as the hash. So I do not want to put the config in here. So it's config, you put in a separate file, right? So let me call this config YAML. I'm going to use the imperative command again. Create config map. Let's call the config map also dov. I like to keep all my resources the same name so that at least it's easy to find. And then I want from literal the instance name is, let's say, hello. Okay, let's put hello first. We can change it afterwards. And then again, same thing, YAML, and then dry run equals to client. Okay, again, let's clean this up a little bit so that it's easier to read. Okay, right. So we can say hello, like hello world. I could have just put a. So this is my config map. The config map is called dov, and let's just go back to here, and then I'm going to add this in. This is env from, and then I'm going to say I'm going to get it from my config map ref. The name is dov, right? So this one references this guy, right? I'm going to pull. I'm going to set a hash name to the name of my pod. So this is what I'll do. Env, the name, which is instance name. Okay, value from, and then we'll say field from field ref, field path. The name, I want to get it from the status. Oh, sorry, metadata dot name. So basically what I'm saying is this, I want the name to come from metadata here. Okay, so let's just deploy this one first. So let's deploy this guy. Okay, let's look at this. Let's look at our. I'm deploying to the default namespace so that it's easier to see. So we can watch kubectl get all CM is config map, show labels, and then what? Okay, so I've got my config map here. Okay. The next thing I'll do is this. I will now create this, expose this. So now it's up and running. Okay, I can. So then the next thing generally you do is that you can either do a port forward. Before I do that, I want to create a service first. So I'll go and create a service. Again, I'll use the imperative command. Create service. I will create a cluster IP. The name is the service name is called dov, and then I'm going to set The 5,000 is the service port. The 3,000 is the port on the port. Okay, and then let me output this YAML dry run client. Okay. Okay, let's clean this up again. Let's clean it up. Okay, let's just move this up so that we can see what is happening. This is the service, the labels. The type is cluster IP, the selector. So remember, this selector selects the port, which is this guy. Okay, clean that. Okay, and then this is the port that is exposing. So port 5,000. This is the service port. This is the target. The target port references this port, right? So we will now deploy this guy again. Let's look at it. The service is up. Where's the service? Okay, the service is up. Let's run this guy by doing a port forward. So we can go kubectl port forward, and then we'll say svc service, the name of the service, which is DOF. So we want to specify the local port, which is 8080, to the service port, which is 5,000, right? Now we can test this guy by doing this. Change this to localhost 8080. And then now we've got our application running. Okay. I think I made a mistake somewhere here. Instance. Oh, sorry. Sorry. This should be instance hash, instance name. So I made a mistake. So what I need to do is this: stop this guy, right? Redeploy this. Redeploy all this. Okay. So wait for it to finish. Wait for this to terminate. So just now, I'm supposed to type instance hash here, right? Because my config map is instance name, right? Okay, so that's why it was overwritten. That. So let's see, right? I'll wait for it to terminate. The reason why it's taking a bit long to terminate is because of the grace period. So let's forward this again. Forward this again. And then now, if I refresh this, notice that the first part here, this is the instance name, and this is the name from the this is the hash. This is the port name, right? So this name, you see this one of the name is here. So it's 4BL5Z. So 4BL5Z. This is the first one. So this instance, we are reference this. Let's say, for example, you know that there is a bug in your code, right? And you want to look at the error, right? So what you do is that you select maybe like this port, and then you would go kubectl logs. You look at the logs. Okay. So we have just run through one cycle of deploying a Kubernetes resource. So this is very simple. It's a very simple resource. Okay. So what we did was this, the Kubernetes development cycle, what we did was this, we develop our application, okay, which I've already developed, and then we write the Docker file to build the container, right? And then what I did was we tag the file, okay, and then we need to push it to the registry, right? And then we write our Kubernetes resources, and then we rendered, we write the manifest, and then the next thing we do is that we deploy the manifest, make sure that it works, and then we port forward, and then we test our application. If anything goes wrong, we go back to here, change this. If there is anything wrong with the application or with the Docker file, we go back to here, we redo the whole thing again. So this is the entire Kubernetes development cycle. Okay, so there's a lot of repeated steps in here, right? So how can Skaffold help? So what Skaffold does is this, right? Skaffold allows you to create a pipeline from all the way from building the image, the image all the way to port forward. Okay, a CI/CD pipeline. It has different stages, like detecting source change, and then when it notices that there's a source change, depending on what has changed, if the Docker file has changed, it will rebuild the artifacts. Optionally, you can also specify a test to test your image. Okay, then tag your images, and then if you got Kubernetes resource YAML file, it will render the manifest, and then deploy the application, and then automatically tail and port forward and tail the pods. Okay, when you kill the application, it will automatically clean this up for you. So now let's say I want to stop this, right? I need to go and manually clean this up myself. Okay, so kubectl delete -f. I need to delete this manually. Okay, let me go also delete this. Okay, so I need to manually delete this myself. Okay, so what Skaffold allows you to do is this, right? Skaffold, you write a file called skaffold.yaml, and then there are a few sections in the Skaffold YAML file. We will look at the build, the deploy, and the port forward. There's another stage in the middle here, which is called test, which we are not going to do today. Okay, so in the build part, you tell Skaffold how to build your image using what method. Skaffold supports a few methods, and I'll show that to you later. We will start. So it has to be a it has to be a container, because this is how it works, right? Skaffold works with Kubernetes. Depending on how what tool you use to build. If you're using Docker, then you just straight use Docker to build. So once that's been built, you tell Skaffold how to deploy your application. Okay, what we're going to show you next is we will use the standard Kubernetes tool, which is kubectl, to deploy the application. So once that's been deployed, you can automatically port forward your application, and then you can get Skaffold to port forward your application, and then tail the logs so that you can look at the logs. Okay, so the way it works is like this: you write one of these files, and then you can either just do build, which will just do a build and then it will stop, or you can do Skaffold run, which will do build, which will do build and deploy, and then it will stop, right? Or if you do Skaffold dev, it will perform these two steps, and then you port forward as well, and then you will continue to monitor your application, and then you repeat this whole step when there are any changes. Okay, so what we're going to do now is this. So the manual steps that I've shown you just now, we are now going to write a Skaffold pipeline to automate our deployment. Skaffold has got a really neat. Let me kill this guy. Skaffold has got a initializer. You can just type Skaffold. You can just type Skaffold init. Where's the init? Where's the init? There's no init. Okay, so there's actually a command called Skaffold init. Okay, so if you type Skaffold init, you automatically generate. It's quite smart. You actually look at the files, and then you automatically generate the original a set of like standard Skaffold file for you. Okay, so what we are going to do is this: we're going to write the Skaffold file from ground up so that you know exactly what is happening, what are the things that involve. So you inside our directory, we will create a file called Skaffold YAML. We will look at the Skaffold documentation. It's quite simple. This is Skaffold documentation. We'll go right to the bottom here. There's this Skaffold YAML file. Okay, there are many different versions, just like Kubernetes resources, right? The latest one is 21. We will use 21. Again, it's very similar to Kubernetes. You write API. The file name is called Skaffold YAML. So I'll write API version Skaffold v2. Was it v2 beta 21, right? 21. The kind is config. Okay, the kind is config. The metadata, you give the name of this file. So I'm going to call it JS build. Okay, it's JavaScript. Now comes the fun bit. I'll leave requires out first for the time being. We look at requires a little bit later on. Okay, so we'll skip the whole require section. The first thing you want to do is that you want to tell Skaffold how to build your image. So the first section is the build section. Okay, you can have, and then you have artifacts. So these are the artifacts. Artifacts. You can have multiple images, right? Notice artifacts is an array. You specify the name of your image. So my name, I'm going to call it DOF. So let me delete. Let me delete this image first. Okay. So make sure that there are no more image here. So you specify the name of the image, but do not specify the tag. Okay, because there is a Skaffold supports something called tagging policy. So you can create like a variable for the tag. Okay, do not put the tag. If you are pushing it to, like, if you're using GCR, for example, like this, and then your name, you can do that, right? So I'm going to push. I'm just going to do that. Okay. The next thing you'll need is the context. The context by default is a dot. Okay, this is the Docker context, right? So generally I like to put it in. At least I want to be sure. So I'm saying that the context is in my current directory. There are other things. These are for file syncs. I will skip this. I will skip all this. Okay, you can also define dependencies on other images. I'll skip this. So this is the part that we want. We're going to use Docker to build. So again, Docker is the default, right? You don't have to actually say Docker, right? Since we are doing this as a workshop, I'm going to put Docker here. Okay, I'm going to say Docker. The default Docker file name is Docker file. Okay, so if you don't know anything, you can just put like this. You just take the default, right? So we'll just put a Docker file here. It's Docker file. So this is the build section. Okay, this is the build section. So now, if I want to just build this, I can just go Skaffold build. Okay, just to run the build section. Okay, so now that it's done. If I got Docker images, so you notice that this is the image that has been generated. Okay, right? So the reason is because it's giving me this is because I did not give a tag. Okay. So the way you want to specify a tag is this right below here. Okay. So there are other ways of building. Of course, Docker is one of the ways of building. The other one is Bazel. And then Jib, we'll look at Jib afterwards. Jib is Java image builder. These are typically for Java applications using Maven or Gradle. Kaneko is a in cluster build. And then we have got build packs. If you got build packs, you know, right? Build packs, you can use build packs yourself, and then your custom build. Okay, so the next one we want to look at is tagging policy. How do we perform a tag? Okay, you can tag your image either by a git commit, in which case you need to commit first before you build. That's how you get the commit. You can tag it using a SHA-256. You'll run a checksum on your image and then use that as a tag. You can specify an environment template which will read a variable from the environment. You can specify date time or some custom template, which is a combination of above. So what we will do is that we'll just use the environment template and we just provide a string literal. And the way we will do that is like this. The tag policy is the same as the artifacts. Okay, so it's under here. We'll use the environment template. Environment template. Env template. Sorry. environment template, and then template. Okay. If you're reading it from the environment variable, you can do something like this. For example, like image version. Okay, and then you go out. You set the variable environment variable called image version to whatever version you want. What I'm going to do is I'm just going to do a literal string like that. Okay, so that's my tagging policy. So let's build this again. Okay, so now it's not building it because it's already built it, right? You just tag it. We'll do an image again. Have a look at the image. So now notice that this is the image that it has generated. Okay. So that's the build part. So you can automate. So this is just building. The next part we want to look at is there's the test, which I'm going to skip. Is the deploy part. So you can do this. Oops. Deploy, and there are many ways of doing deployment. There's Helm. If you work with Kubernetes, you know Helm is a package manager. You can use KPT. KPT is a Google tool which I've not used. You can use kubectl, right? So we're going to use kubectl to, in other words, Skaffold is going to use the kubectl command to do deployment. And the way you use this is you go kubectl, okay, and then you can specify the manifest. What are the manifests? What are the Kubernetes manifests? Okay, this is a list. So you give a list of the file name. So I've got two. The first one is a config file, and the second is my deploy file. Oops. Okay, my deploy file. You can also provide. You can also have remote manifest on remote clusters. You can also provide flags. Okay, when it's doing apply or delete, whatever. Okay, so let me show you one. So for example, since I'm doing development, I want to speed up the redeployment, the delete, right? So I can say flags. Let's say I want to pass additional parameters into kubectl delete. You can do delete. So this is an array, right? So we can do like this. So one of the thing is, so if you look at kubectl, so these are some of the options, right? So one of them I want to do is grace. There's this grace period. Where is this grace period? Is it here? Okay, so the grace period. Okay, so I want to make it, delete as fast as possible. So I'm going to set like grace period. So let's just set it to 1 second. The default, yeah, okay. So when you do delete, when it does delete, it will, you do a kubectl delete on all these resources. You add this. So you can add, you can have any number of flags for any number of the commands. So that's the deploy. And then finally, the last section that we'll look at is the port forward. Okay, so we go port forward. Port forward is a list. It allows you to port forward any number of resources. For us, it's only one. The first thing you need to do is you need to say what is the type of resource that you are going to port forward. It supports like service port, replica sets, deployment, stateful sets, etc. Resource type, we will say service. Okay, resource name. Name. The resource name is DOF. The service name is DOF, right? And then we will have port and local port. Port is the resource port. That means the service port. Local port is is the port that we're going to forward to on my local machine. So this is the service port. Service port is 5000. Okay, let's go back to deploy here. This port here. Okay, and then I'll say local port 8080. Right. So now what we'll do is this: we'll now get Skaffold to continuously monitor our application. So we'll go dev. Oops. Sorry, I need to be inside directory. Oops. Okay, this is the SL command. This is fun. Basically, if you type wrongly, it will show a train. Okay, so I'm inside JavaScript, so I go Skaffold, dev. There's an error in line 21. Oh, spelled incorrectly. Okay. So now it's going to go out and it's going to now start deploying all the applications. So it's port forward, and this is so yes, port forwarded from 5000 to 8080. And then what it has done is it has also tailed the logs of the two of the two ports. Okay. So now this is, notice that it's actually coming from here. So now if I do this right, if I now go back to my deployment and I now change the replica, change to 1, I change this, you start redeploying again, and then it's going to kill. It's going to wait until the application stabilizes. So it's terminating. So obviously I set the grace period to 1 second. It's not working. Okay. Let's just wait for a while. Force delete. Yeah, okay. Right. So I can put a force. So someone suggested I can put a force. I can do a force. Okay. So now if I do a reload on this, notice that this is up, right? So the other thing you can do is this, right? If I go to, let's say, for example, in my Docker file, I want to change this. I want to add this part into my Docker file, right? So the way I'm going to do this is like this. The first thing I'll do is this. I'll go to my Skaffold file. I'll change the template to 2 first. Okay, change my Skaffold to 2. So that will cost a reload. So it doesn't really matter. Then what I'll do is I'll come back to my Docker. I'll come to my Docker file, and let's say you go and update your Docker file, right? So you do a save here. So this will start rebuilding my Docker file. Okay. So now I've rebuilt my Docker file to version 2. So this is the first version. This is the second version with the health check. Okay, so I've built that, and then now I can go back to my deployment, and I will now change the image to 2. Okay, so you'll now start doing the redeployment of the entire application using version 2. Okay. So one thing it cannot do is this, right? So this is really nice, right? So let me show you the other thing that. So this is one of the annoyances with Kubernetes. If I change a deployment file, right? So let's say if I change a config map. Okay, so what Skaffold is going to do is that Skaffold is going to redeploy. Okay, but notice that nothing happens to the to my pod. Okay, so if I do that, nothing happens to the pod. And the reason is because, right, unless the config maps are mounted into the pod, if you change your config maps or secrets, it will not affect the pod. Okay, in other words, the pod will not know about it. The only way is to actually kill the pod and get Kubernetes to get the deployment or get your replica set to redeploy the pod, and then the new pod will pick up the configuration. Okay, so what we can do is this. I'm going to kill the pod, delete PO. I'm going to use a selector. I'll use this thing, right? The app name for the selector, the labels for the selector is app.dof. Okay, app.dof. So it's going to kill these. It's going to kill the terminate the pod. Again, it's okay. I should put, maybe I should put a false. Okay, so one of the really sad thing about doing demos with Kubernetes and Docker containers and stuff like that is that you need to wait for for things to stabilize. Okay. Come on. Okay, so now if we now go back to this thing, just let the service pick up the service endpoint pick up the new pod. Okay, so now it's pick up the new pod. Okay. So remember that, because we're going to come back to that. So right. So now let's say I'm done, and if I stop this, if I kill this, what Skaffold do said, it will just kill all my pods for me. The only one is that, right? So you'll just clean up all my resources for me. So that's very nice. Okay. So these are for the Java people. So if you're doing a Java application, right? So I'm very quickly run through this because I just realized I'm running out of time. So if you're doing Java application, this is a very simple Spring application. I won't show you the application. It's basically the same thing as the DOF, but it's written in Spring. So the way you do is that you go mvn compile, and then you go mvn spring boot run. So it's now running on port 3000. So we go back to port 3000. Okay. So this is a Java version of the same application. Okay. If you're using a Spring application, the way you integrate it into, like if you're writing a microservice, with Spring Boot or any of the Java RESTful application, RESTful framework, there's this plugin in Maven called Jib. So this is the build portion, right? This is a Spring Boot. This one is the Spring Boot run. This portion is the Jib, JIB. JIB stands for Java. I think stands for Java Image Builder, and this is the Maven plugin. Okay, so the way you do is that you put it under the build section. It's actually not very powerful. I mean, if you can write a Docker file, it's actually a lot better, because this is actually quite limited in what it can do. But if you just want to be, if you just building a standard image, then Jib is actually pretty good. So you get the plugin, the group ID, the artifact, the version. The thing you need to do is that you need to configure. You need to configure the name of the image. So I'm going to call this DOF Java. You can also optionally specify tags, a tag for this. I'm going to leave this blank. The reason is because afterwards I'm going to use a Skaffold. I'm going to get Skaffold to provide the tag. You can also optionally specify, say, the port that your application is exposing. In this case, it's port 3000. Okay, and the way you use it, if you're not using, so I'm going to show you, if you're not using Skaffold, you just want to, use this in your Gradle, in your Maven environment. The way you do is you go mvn compile, if you haven't compiled, you need to compile it. And then you go zip, okay, Docker build. So let me show you first Docker images. So it's not here, right? So you go mvn, compile, zip, Docker build. Oh, no. Okay. One thing I don't like about Maven is that if you haven't primed your repository, it's going to download half the internet. Okay, so while that is going on, let's just write our scaffold file first. Okay. Why does it say okay? Okay, so what I will do is this. I'm going to copy the file from JavaScript. So I'll call this Java build. I don't want to deploy the application. I'll just show you the build part because it's the same application. I'm going to call this image dov Java. Okay, and instead of using Docker to build, let's see this. Okay, so it's completed. Sorry. So notice that this is the image. Because I didn't specify the version, I didn't say what version it is. It's going to give me latest, which is a bad practice, right? So we don't use latest as our version. I'll show you zip, how to use zip. This is zip. Where's zip? Okay, this is zip. It goes under the same section as Docker. And the only thing you need in zip is to say what type is it. Is it a Maven or Gradle? Okay. The tag policy, I'll put it version 3 Java. Okay, so now I can go scaffold build. Now, if I go Docker images, notice that I've used Maven to, I use Skaffold to build my application using the zip build, right? Okay, so there's this scenario, right? So it's very simple. Then you do the same thing with deploy, etc. Okay, so there's this scenario. For example, let's say you are in charge of a project. You're writing a project, and you're writing a microservice, and then you've got many microservices, right? So let's assume that there's one microservice here and there's one microservice here, and you want to test every one of these microservice is their own. They have their own containers, Docker file. They have their own Kubernetes file. They have their own scaffold, and you're testing them individually. Okay, so you have Java, and then you have like JavaScript. So let's just imagine, this is different. This is like not the two, right? Okay, so now what Skaffold allows you to do is that Skaffold allows you to write one Skaffold file that manages all the other sub Skaffold file. Okay, so let me show you what I mean. So right at the top of your root directory, right, you can create a file called Skaffold. Okay, so I'm going to copy from Java Skaffold. Oops. Java Skaffold. Okay. Okay, so let's call this Uber build. Okay. So remember, this is right at the top, right? So now we can say this. Okay, we can say requires. What are the dependencies? Requires. Okay, you can pull from Git. Okay, you can specify, you can say your application is coming from Git, but I'm going to just use path. So you can say path One of them is in Java. And then the other one is in JavaScript, like that. Okay. So now I can go Skaffold, build. What you'll do is this, since we are referencing the top directory, it's going to go into these two directory, and it's going to start building those two things. Okay. And the really nice thing about this is this, I can, right at the top directory, I can go Skaffold, dev. Okay. So since every one of those directory is its own microservice with its own Docker file, like one is, you know, own Docker file and its own Kubernetes resources and its own Skaffold YAML, the top level Skaffold will just deploy, go into this subdirectory, look at the Skaffold file and start deploying all those things. Okay. So now, for example, if I'm working in here now, JavaScript, if I'm working in here, and I now want to change this to, let's say I make some changes here. Okay. A nice thing about this is that the top level directory will pick it up and then we'll redeploy everything again. Okay. So this is a really, really cool feature. Okay. Right. So for Skaffold, I will stop here. That's the end of the Skaffold section. So we are going to move now to the next section. If you're working with Kubernetes manifest, there's a lot of situation. There are instances where you come across this. You have written one set of Kubernetes resources, like for example, like, you know, I've written it for so the question is, redeploy everything refers to really everything or just the affected projects? Just the affected projects. Okay, just the affected projects. So So in a lot of in a lot of situation, you will find that you write one set of Kubernetes resource. You have to do testing on perhaps, you know, maybe when you do dev, your replicas, you know, you may not want to have so many replicas. You may want to have like a different database. When you do testing, you may want to have more replicas. You may want to have maybe you know, maybe a sidecar, right, to do some policy testing, whatever. Okay, and then in production is different. So the default Kubernetes, right, the default Kubernetes manifest file, there are no really built-in way to parameterize the manifest. For example, if I'm in JavaScript and this is my deployment, oops. Let me come back to here. Right? Okay, so there's really no nice way to deploy this. I cannot say that, oh, this is a parameter. The default Kubernetes manifest doesn't have this feature. Okay. So what you do is this: if you've got different environments, some of the alternative is, the first way, of course, is to fork it. You create different directories, you copy this file over. So let's say I want to change this, right? I will just manually copy this file in my test environment and change this. Okay, so that's one way. A second way is to actually write a Helm chart. Most of the Kubernetes applications are deployed using Helm chart. Complex applications are deployed using Helm chart. However, writing Helm chart is actually not really that simple, because Helm has got its own function. You need to invest time in the development. And one of the really bad thing about Helm is that Helm is like a programming language. You know, because it uses templates, and templates has got logic. It's not logicless. It's logic. You need to test the template. And the other really bad thing that I do not like about Helm chart is this: when you write a Helm chart, you need to anticipate how the users are going to use your Helm chart. In other words, you need to figure out what are all the possible use cases that people are going to want from your chart. So it makes, in some cases, it makes Helm chart very, very complex. There's a lot of configuration parameters in the config in the value file, in the values file. Okay, so the alternative, one of the alternatives is to actually use something called Kustomize. And the way Kustomize works is like this: you provide it with a base, you provide Kustomize with a base resource file. So example, This could be a base resource file. Okay. This could, like, let me say this one. So this could be a base resource file. Then what you do is that you provide a patch. And what Kustomize will do, many times you don't really need the patch. Okay, the patch files is needed when something that Kustomize cannot handle, doesn't provide a nice way. I'll show you after how it works. So the idea is this: you write a base file. This is like a generic deployment, and then for every environment you write a patch file. Okay, for the patch file you don't need to repeat everything. You just need to provide enough context. And then what Kustomize will do is that Kustomize will combine these two into a new output. So this is the file that Kustomize will be deploying. So very simple idea. Okay, so no forking. You do not need to write Helm chart. And then, how you use it really depends on how you write your patch. Okay, and so generally the way people use Kustomize is like this. You have the base. This is your base application. Okay, this is your resource. And then inside your base, you write a customization file. This customization file says, what are the resources in here that can be customized? And then you create a directory called overlays. You don't have to follow this. This is sort of like the general practice people do. You create a directory called overlays. And inside the overlays directory, you create subdirectories. These are your different environments, right? Then you write your customization file. The customization file is basically points to this file and say, how do you want to customize this file? So one for different environment. Okay, it is actually a lot simpler than what I described. So let's go and look at how we customize our application. So this is my base directory. This is my base application, right? What I'll do is the first thing I'll do is this according to my diagram here. So let me show you customization first. Customize. This is a customized directory. We will go to the core docs. Go API guide. Okay, so the customization file again looks like this. So remember, this is my base directory, right? So you create a file called customization. KUS station YAML API version customize config k8s.io v1 beta 1 v1 beta 1 v1 beta 1. Okay, so the kind is customization. So remember, this is the base directory. Now we want to say, what are the resources in here that can be customized? Okay. Obviously, I want to go deploy. Okay. So I'm not going to put the config file, because config file is not something that you want to custom. Config file is something that's provided in different environment. So I'm only saying that the deployment file is the only thing you can customize. Okay, so this is the deploy file. Okay, so that's it. So now you come here, we will follow the customization convention. We'll create a directory, overlays, and then I'll just call it like dev environment. Oops. Now I will create my customization. So this customization, imagine, is for doing development. KUS optimization. Okay. So again, I'm just going to copy that file across. JavaScript customization. Okay. So here, so this, remember, so this is now my dev environment. So this is my customization for dev environment. The resource I'm going to say is in this JavaScript file. Okay, so Kustomize will automatically go and pick up the customized file inside JavaScript. Now we will do our customization. So there are a lot of these things here. So let's do the simple one first. we can add labels, new labels to all our resources. So we can say, according to this, so these are the simple ones, common labels. Okay, so I can say, you know, env environment, maybe dev. So every resource will now have a new label. Let's say I can also do things like name prefix. I can also append prefixes to names to all the resources. Okay, so name prefix, maybe I can say def, just put a def. You can also have name suffix, which I'll just leave that alone. Okay, so let's see what this one generates, right? So this is very simple. Let's see what this one generates. Let me go to my customized directory. Okay, again, you have to download the customized binary. So the way it works is like this: you just go customize, build. Okay, so let me put this in a YAML file so that you can see it properly. So customize, build, and this is what is output. This is the output from the customize. Okay, so based on the using the base directory from JavaScript, it has now added for every resource. It has now added the dev environment. So under service is added the dev environment. Okay, notice that it's also smart enough, right? So notice the selector. So deployment is added the dev environment, and in the pod template is also added dev environment. Notice also very smart. In the service selector is also added the dev environment, and also in the deployment selector is also added the dev environment. The second thing is that all my resources is prefixed with the DOF. Okay, so how do we run this? So the way you do that is like this: you go you go customize, build, you pipe it because it outputs a YAML file. You pipe it to kubectl. There's another way to do it, right? I'm just showing you the basic first. Kube, kubectl. You go apply -f dash. Okay. So now this will fail. The reason is because there is no config. Okay. So notice that. Okay. The reason why it's failed is because there is no config. There is no config. It cannot find the config. The config map called DOF, right? Okay. So it cannot find this thing. This name. Okay. So if you want to delete, okay, you force the delete. Okay. So let's write the config file. Let's write the config file. So one of the nice thing about Kustomize is this. There is a config map generator. Okay, so the way it does is like this: you go config map generator. Okay, and the config map generator is a list. So you say name. What is the name of the config map? The name of config map is DOF. The original name is DOF. And then just like the kubectl create config map, you can have file section. You can either create config maps from files, from environment, right? From literal. I'll just use literal. So you go literals, and then you give a list. So it'll be instance name. I can say hello Kustomize, like that. Okay, so I can redeploy the whole thing again. And now it should work. Okay. So the nice thing about customize, if you're using Kustomize, is this, right? So I can deploy using Kustomize build apply -f, right? So the nice thing about Kustomize is this. So remember, we have been deploying our application, Kubernetes application, right? Using kube. I'm showing you the command here, right? kubectl apply -f, and then the name of the file. Okay, like for example, like deploy, for example. Okay, Kustomize has been integrated into kubectl, so you do not actually need these two steps. You can do it in a single step, like this. So instead of using K, instead of using F, you use K. Okay, and you put dot. Where is the directory where the customization file is found? So you do like this. You hit enter. It will automatically redeploy the 3 files for you. Okay, so now this is running. So this is running now. We want to test our application. So what we do is this. We do the same thing, right? We want to test our application. We go port kubectl port forward. And then we want to say the name of my port service is now called dev.dof, right? SVC dev.dof. And then the port, the local port is 8080, and then the service port is 5000. Okay, let's try this again. Oh, this is 3000. I want 8080. Right. So this is from Kustomize. And again, if there is, if I want to look at the, if I want to tail the logs, I go kubectl logs -f deploy. Let's look at the deploy dev. So that's the, oops. That's the logs. Okay. So notice what I did, right? With Kustomize. I write the Kustomize file. I deploy it using kubectl apply K instead of apply F. I go apply K. Once that's apply, I go port forward. Test my application. If there is any error, I look at the logs. Okay. So this is actually the same step that we did previously with native Kubernetes resources, the deployment, right? So the nice thing about this is that Skaffold actually has support for Kustomize. So we don't have to go through this process again. Okay, so the way it works is like this. So let me kill this guy first. Okay, and let me delete this. Okay, so now we'll write a Skaffold file. Okay, I will copy the Skaffold file from, I'll copy a Skaffold file from JavaScript. Okay, I'll call this custom build, dev build. Okay, I do not want to build my artifacts. In here, I only want to write customization, so you can remove the build section. Okay, the deploy section. Now, instead of using tag policy, so the deploy section, instead of using kubectl, I will now use Kustomize. So it's very simple. Kustomize, you say the path. Okay, we'll do the same thing with flags. Let's try the force. Okay, everything else is the same. Now the service name, so it's no longer DOF. You need to go DEV DOF. Okay, So now we come back to here. We just go scaffold dev. Oops, there is an error in line 7. Deploy, customize. So it's customize, path, customize, paths as. Okay. Okay, so now customize has got this thing up. So now it's doing customize. Okay, so I can now say, one of the things I can now do, so this is my scaffold file. One of the things I can now say is this. So let's say I want to change the replicas, the number of replicas. Okay, so this is my replicas. Customize. The name, this is the deployment name, the original name, and then count, I want to put it to 2. Okay, so this will now start redeploying again. Okay, I've now got two replicas running. Okay, so the other thing about this is that, so notice, remember just now when we are using Skaffold, right? I changed the config map. The config map is the new config map is deployed, but the pod hasn't picked it up. Okay, so here, right? If you're using customize, I can just change this. So this is the original one, okay, color customize. So if I now change this, right? The nice thing about this is it's going to redeploy. You'll kill all the pods and restart the pods for you. Okay, so it's terminating. So you don't need to terminate the pod yourself. Wait for this to finish. Okay. Okay. So yes, we have changed the pod. Deploy the config map and then redeploy all the pods. Okay. So there's actually quite a lot of things that you can do with customize. Okay. If something that you want to customize is not supported in here, right? So customize allows you to create patches, and this is the last one we'll look at, and then we'll end the session. So let's say this. Let me show you the image first. How you can change the image. So remember, currently I'm now running on the default image is the JavaScript, right? I want to use, let's say I want to use this Java image, right? This image. And the way to do that is that you need to know the name of the image, which is DOF, and the version. So you go here, images. The name of the image is DOV. Then you give the new name, DOF Java. And then generally there'll be a new tag, v3 Java. Okay, so that's the new tag. So this is now going to redeploy, and then it's going to it is going to use the Java image. Okay, so while that's going on, if you want to customize something that is not supported in here, For example, I would like to, since I'm using Java, I would like to restrict, or I like to raise the requirements, the resource requirements for my pods, right? You know, because if you look at currently now, you can go cube Cuttle describe pod selector app equals to DOF. You will see that currently there are no resource requirement, you know. So I may want to set some resource requirements in here, but it is the customization of the resource requirements is not supported here. There's nothing here. In that case, we will use something called patch strategic merge, and this is how it works. Let's go back to this customer directory. Okay. You can write the customization directly inside the customized file. Okay, generally what I like to do is I like to write it in a separate file. And the way you do that is this. I'll just say add resources. Okay, and what you do is this, right? Go back to the original file. Remember, we are going to add resource. We're going to specify the resource request and resource limits for this container. The way you write a patch file is to provide it with enough context for Kustomize to do the patch. Okay, and the way it works is like this. So the way the context works, always start from the top and select this thing. You don't need the labels, but you do need the name. Okay, and then you go spec. Okay, so that's here. Then you do template. So you're like building a path to it. Template. Okay, template. And then you say spec. So under template, you have spec. And then you have containers. Okay, give the name of the container. So now we have specified the context all the way up to here. Now Kustomize knows what to do. We are now going to add the resource requirements in here. So you can now say request resources request. Let's say CPU. I'm going to request 128 M memory. I'm going to say 256 meg. And what I'll do is this. I'll go limits 256, and this one, oops, 512. Okay, so this is my patch file. We will go back to our we'll go back to our customized file. And then what we will do is this. You have a section called patch strategic merge. And then it's just the name of the file. Okay, so if I do this, Skaffold will now start redeploying it again. Okay, so while that's building, one of the questions I have is, Kustomize is built into kubectl, I think as of version 1.14 or 1.15. Okay, if you want to look at, so sometimes it's good to look at what is generated, because you may not be sure. So in that sense, if you just want to use customization, you don't need the customized binary. But if you want to look at what is generated, there are two ways you can do it. Of course, you can use kubectl. You can do a dry run, dry run client, and then do output YAML. That's one way. The other way is to just download the customized binary and just do customized build. Okay. So that's another. Okay. So let me finish this first, and I'll answer your question. So we've got this up and running. So we can now look at our pod, and now you notice that we have now got the memory requirements here. Okay, so this is how you do patching. Anything that's not supported by what is displayed here. There are so a lot of things that you can do, which I've not gone through.